Good morning, all of you. How are you? This is the first class, right?
Yes, sir.
So, what are you going to study today? Good, that all you know. So, geography. When was the last time you studied this subject? Class 10, I think, or later also. Class 10, right? So, basically we try to understand what is geography. How would you define it in the simplest way, simplest term?
Study of Earth.
Study of Earth. We have two things. Geo. Geo means Earth, and graphy. Graphic is description. Okay, so in simplest term, we can say geography is description of Earth. Okay, description of Earth. And for the first time, this term was coined by a Greek scholar referred as Eratosthenes. The Greek scholar by the name of Eratosthenes. He was the first who coined the term that we call as geography. Right. Now, in the UPSC, we have to study geography, and which we can divide into several sections. So, this is based on how our Earth looks like. Okay, if you talk about Earth, it is made up of what? You have the land mass, okay, then you have the water. Surrounding the Earth, what do you have? Atmosphere. Okay, so, study of each of these, what you can say, the domains of the Earth is what we have to study in geography. So, first is the land part, what it is referred as? Right, the solid part of land, solid part of Earth, you can say, is referred as lithosphere. Litho means rock. Okay, so rock is sphere, that is made up of solid rocks. So the rocky part of the Earth. So, lithosphere. The study of lithosphere is done in the branch of geography, which is referred as geomorphology. Geomorphology. The first branch of geography is geomorphology. That is study of the solid part. So we have geo, morpho, and logy. Geo stands for Earth. Morpho means forms, and logy. Logy comes from logos. Logos means what? Study. Right. So study of the forms of the Earth. That's how also in simple term we can define it. Study of the forms of the Earth. That is geomorphology. Right. So that is forms means what can be example of the forms on the Earth or of the Earth. If you look at the land part, again think, what are we studying here? The solid surface of the Earth, the rocky part of the Earth. Is it uniform or non-uniform? Right, we have variety of features, diversity. What are the examples of diversity? Mountains, okay, plateaus, then plains, right? We have the desert areas, then we have cryosphere. Okay, what is cryosphere? The Arctic region, Antarctic region, that is the area which is permanently covered under snow as such. So all these diversity, when you try to understand how did they come into existence, what kind of changes we are witnessing, okay, what kind of role they play in determining the climate of Earth and determining the weather of the Earth. So all of this is referred or studied in which branch? That is what we call as geomorphology. Okay, so study of various forms of the landform. That's where we will start also our discussion. Okay. Then after this, the second part of the Earth, second domain of the Earth, we can say, is the atmosphere. The thin envelope of gases that surround the Earth. So we have atmosphere. And the study of atmosphere is carried out in the branch of geography which is referred as climatology. Climatology. Right. So climatology, two things we use sometimes. One is weather and other is climate. Okay, weather and climate. Are they same or different? Different. How is weather and climate different from each other? Yeah, what we are doing first of all in classifying both weather and climate, we are measuring some parameters such as temperature, precipitation, that is rainfall, okay, atmospheric pressure, wind direction, wind speed and all that. If you are measuring it and defining it over a short period of time, what do you call it as? Weather. Okay, so you can say that today outside we have cloudy weather or sunny weather, okay, or windy weather. Climate on the other hand is the measurement of the same parameter, but they range over a long period of time, okay, or more than 50 to 100 years and all that. So that is the difference. So we will try to understand here both weather as well as climate. So the study of second domain, atmosphere, that becomes the second branch or the second part of your geography syllabus, which is climatology, right? So first, what do we have? First part of syllabus is geomorphology. Okay, second part is climatology. Now what is the last domain left? What else do we have apart from the land and the air around us on the earth? Right, we also have the water. So the part of water is referred by what term? Hydrosphere. So hydrosphere. Hydrosphere, and the study of hydrosphere, because 97% of Earth's water, almost we can say 97%. 97% of Earth's water is found where? Ocean itself. Right, ocean. So that's why the study of hydrosphere is carried out in the branch of geography that we refer as oceanography. Third branch of geography. Oceanography. So three branches. What we have till now: geomorphology, climatology and oceanography. Collectively, when you look at them all together, they are also referred as physical geography. Okay, so physical geography, the section physical geography consists of the three branches, that is geomorphology, climatology and oceanography. And this collectively makes up roughly, we can say, 60 to 65% of your entire UPSC syllabus. Okay, these three together, the geomorphology, climatology and oceanography. And this branch is relevant for both means we can say even all the three stages of examination. These are prelims, mains and interview. Okay, so for all the three stages, this particular branch, the physical geography branch, is very, very important. Plus this is also where you have the concepts of the geography lies in. This is the core of geography. If you understand this branch, it is easier to understand all other part of the syllabus that we have: Indian geography, economic geography, human geography and all that. Right, that is the first section. Then apart from that, two small sections we can say we'll be studying about obviously. So geography, entire details of India, Indian geography, and then we have in Indian geography we have several sections such as physiography of India. Physiography of India, right? River system we have to study. River system. We have soils, natural vegetation, climate of India. So these are the 5 main chapters which comes under Indian geography. Physiography of India, river system, soil, natural vegetation. Natural vegetation is forest also we can say. Natural vegetation or forests of India. The types of forest classification and all we have to cover. And then the climate of India. Then economic geography, a small section, not have to go in very much detail, and the human geography, 1 or 2 chapters you have mainly important from exam perspective. So economic geography, human geography, industries, resources, and all we will be studying here. Understood? That means entire syllabus we can divide into how many sections? Total we have 4 sections. First is what? Physical geography. Second what we have? Indian geography. Third is economic geography. And fourth is human geography as such. 65% roughly I told you physical geography part. Okay, about roughly 25 to 30% is Indian geography. And then 15% around we can say the weightage of economic geography and human geography. Okay, considering all the stages, prelims, mains and interview. So have understanding, okay, got the understanding of the syllabus, okay, basic understanding. Now we will start with the which branch first? First is geomorphology, okay, about the earth, lithosphere part. So we can give the heading geomorphology. Geomorphology. Here first we have to understand about the basics of earth. Basics of earth. Right, basics of earth. So first is the motion of earth, we have to understand. Motion of earth. Motion of earth means we know that earth is engaged in 2 type of motion. What motion? Rotation and revolution. So 2 motions. So first is rotation of earth. Rotation of earth. So why does earth rotate? First question is this. Earth is rotating, every one of us experience day and night because of the rotation. Why does earth rotate? What is the reason? It is because in the initial phase when everything was forming in the solar system, they had huge amount of energy. So earth is rotating because of the initial energy that was provided to it. right? That means we can say as the time passes, what would you expect? Rotational speed will increase or decrease? Okay, all of you must have seen a spinning top. What do you do? You tie rope around it and then you throw it. When you throw it, what happens? In beginning, it start to rotate at rapid speed. After gradually, what happens? Gradually, it start to slows and finally comes to halt. So, what is the reason behind this? Because the energy that you have provided gradually dissipates. Okay, why? Because the ground friction acts, air friction acts, and all that. Similarly, Earth also experiences a lot of forces while it is continuously rotating and revolving around the sun, right? So we can say that you can write the statement that the rotation of Earth, is largely due to the rotation of Earth is largely due to the initial energy due to the initial energy provided to it initial energy provided to it at the time of origin. Initial energy provided to it at the time of origin. Then second point, gradually as the energy dissipates, gradually as the energy dissipates, the speed of rotation, as energy dissipates, the speed of rotation decreases. Speed of rotation decreases, and we have the evidence of this. So scientists, based on the study, what they have proved, that if you go back somewhere about 900 million years ago, what is the age of Earth, since we are talking about it, right? About 4,500 million years. So Earth came into existence 4,500 million years ago. So since then it is rotating, and as it is rotating continuously, it is losing energy. So scientists believe if you go back in the past 900 million years ago, rotational speed was faster, and it is obvious that if rotational speed is faster, the length or the duration of day will be what? Shorter. Okay, so today we have 24 hours of the duration. That time what was duration? Only 19 hours. Okay, so that is the example we can write to understand how rotational speed is reducing. So 900 million years ago, you have the day length of just 19 hours. 19 hours. That means going forward in the future, what will happen? Today we have 24 hours, after some time it will 25, 26, 27, 28, right? So day length is expected to continuously increase. Right. Now the question is that what are the effects that we feel due to the rotation? Effects of rotation. What is the effect of rotation? So three things we can highlight here. First, because of rotation, what do we experience? Day. Okay, sun comes in the sky, then sun goes in the other part of the earth, then what do we experience? Night. And between both of them, what is the phenomena or the duration of day called as? It is called as between day and night. What do we have between day and night? The part of the day is called as twilight. Okay, so both in the evening and the morning, okay, you see something that is called as twilight, experience something that is called as twilight. So day, all of you understand. Night, all of you understand. What is twilight? In the morning when you wake up, okay, what do you see? There is a light, despite sun is not above the horizon. So that phase of the day when you have light, kind of soft glowing light, we can say, without sun in the sky, without sun above the horizon. And similarly, in the evening, what you see when the sun sets beyond the horizon, still it's not complete pitch darkness. You have some amount of light is there for certain duration. So both in the morning and the evening, that soft glowing light when sun is beyond the horizon is what we refer as twilight. Okay, so we can in simple line describe it. Okay, twilight. What is twilight? The soft glowing light in the sky, soft glowing light in the sky, soft glowing light in the sky that is observed, soft glowing light in the sky that is observed when sun is beyond the horizon, when the sun is beyond the horizon, right? That's what you call as twilight as such. So sun has set in the evening, or sun has not even, okay, sunrise has not taken place in the morning, still the light you are seeing in the sky. So that is the light which we call as twilight. Now twilight is of three different types that we have also to understand. Types of twilight. Okay, so imagine that you are talking about any particular place. This is the place on the earth. That means the straight line we can draw, parallel line. This will be representing your horizon. Okay, and as long as sun is above the horizon, you have day. Suppose we are talking about evening. In evening, what is going on? Sun is gradually going beyond the horizon. So when sun reaches here, now what happens? Sun is no longer visible in the sky as such. So when sun is no longer visible in the sky, then we can say it is the beginning of twilight. Now sun is gradually moving away from the horizon. So imagine that sun has moved and had reached at this place. And the angle, this angle that you calculate is how many degrees? 6 degrees. Right, this parallel line that you have drawn is how many degrees? 0 degrees. Okay, so from 0 degree to 6 degree, if sun is anywhere in this range, okay, you are experiencing twilight. What do you call this twilight as? It is referred as civil twilight. Okay, so we can.
Sir, what does the circle represent, sir?
That is Earth. Right, so this is your Earth. So 0 to 6 degree, you can say it is civil twilight. Why civil twilight? Because everyone can experience this twilight in the sky. Okay, every person who is in this particular place, he will see kind of soft glowing light in the sky. Then sun keeps going beyond. The time will come when will sun go from 6 degree to 12 degrees, right, in this area. So when sun is between where to where? From 6 degree to 12 degree. That is the other type of twilight which we refer as what? Called as nautical twilight. Civil twilight. We have nautical twilight. Nautical twilight. Why nautical? Nautical refers to which area? Which part of the earth we use the term nautical? In the ocean. That means only when you are far in the ocean, you will be able to see soft glowing light in the sky. From the ground surface, from the land mass, now what would you see? You will see complete darkness as such taking over. That is the reason why we are calling it nautical twilight. 0 to 6, civil twilight. 6 to 12, nautical twilight. And then sun goes between where? 12 to 18 degree. If sun is in this range, it is referred as astronomical twilight. Astronomical twilight. So these are the three type of twilight, and if sun goes beyond 18 degree, it means now what phase of the day you are in? You are in the night. So now twilight has ended, and we can say the night has begun. Understood? Okay, what is going on? Earth is, imagine that you're looking at the earth from top. This is the polar areas. And what is happening? Earth is rotating like this. So what actually moves? Does earth move or sun moves? Earth moves. Sun is a stationary in the sky. So as earth moves, what happens? The relative position of sun also changes. So as long as this particular place you are standing at, so this is your horizon. So now you have sun in the sky. As earth moves more, what happens? You go beyond the horizon. So sun moves like this as earth keeps rotating. So from 0 to 18 degrees, that is the duration of twilight, which is classified in 666 degrees angle, referred as civil, nautical and astronomical twilight. Why astronomical? Same thing. Now if sun is beyond 12 degree, even in the sea, if you will not be able to see any light in the sky, it will be complete darkness as such. When you can see light? Only when you go up in the atmosphere. Okay, so then only some amount of light you will see coming from the sun itself. So that is why we are calling it astronomical, seen from the atmosphere, upper part of the atmosphere. Understood? Now the question is, why this twilight is taking place? Sun has set beyond the horizon. Still, why are we able to see the light of the sun? Why we do not experience complete pitch darkness?
Atmospheric refraction.
Okay, so sun is beyond the horizon. It does not mean it has stopped sending the beam of light as such. So beam of light, for example, sun is here. It is sending the beam of light. It is not coming directly to you, but where it is going? In the atmosphere. And it goes in the atmosphere, the light is then diffracted, reflected, reflected, everything. So basically that is the region. So this is the three things: the occurrence of day, occurrence of night, and the occurrence of twilight can be considered as a result of what? The rotation of earth as such. That is a simple first phenomenon. Second type of motion which earth exhibit is referred as what? Revolution. So we can write revolution of earth. Revolution of earth. So two things we have to understand. First of all, if suppose this is the sun and earth is revolving around the sun. So does earth revolve in a perfectly circular orbit or elliptical orbit? Elliptical orbit, right? So we know all of this. The sun and earth is revolving around in the elliptical orbit. So as the earth revolves in elliptical orbit, in the entire journey, we know that it takes roughly how much time for earth to complete one revolution? 365 days and what else? 6 hours. Okay, this is the exact time taken by earth to complete one revolution. So 365 days we have classified it into a year, and then we have 6 hours to keep on accumulating, and at the end of 4 years what do you have? 24 hours. That is one day added in the month of February, okay, which we call as leap year as such. So 365 days. Now during its journey, what happens? A time comes when the earth becomes closest or nearest to the sun in the entire journey, and at one point what happens? The earth becomes farthest from the sun itself, right? So in this case, let us imagine this is the closest. At this place, the earth and sun are at closest distance, and at this particular place the earth and sun are at farthest distance from each other. So this position when earth is closest to the earth is referred as perihelion. Okay, the terms here are very important. That's from where questions are generally asked. So should be clear about what do we mean by term perihelion. Perihelion, and the position of the place where earth is farthest from the sun. that place is what we refer as? Referred as aphelion. So we have perihelion, aphelion. At perihelion, Earth is closest to the Sun, and at aphelion, Earth is farthest from the Sun. Now, in 365 days, perihelion is experienced around 3rd of January. Look at the year. Generally, around 3rd of January. 3rd of January, we experience perihelion, while on 4th of July, experience what we call as aphelion. Right? That means what we can say, on 3rd January, Earth and Sun are at closest distance, and at 4th of July, on 4th of July, Earth and Sun are at farthest distance. Okay, so the aphelion, perihelion. If you have to write the distance, not that important, but to have a comparative understanding, at perihelion, what is the distance between Earth and Sun? Roughly 145 million kilometers. While at aphelion, it increases to how much? 152 million kilometers. So roughly 7 million kilometers of difference we observe. 145 million kilometers on perihelion and 152 million kilometers in the aphelion. Understood? Clear? Now, exact same thing we see in the case of Moon and Earth system. The way how Earth revolves around the Sun, Moon is orbiting around Earth itself. Moon also orbited which kind of orbit? Kind of elliptical orbit. So what we can say? Moon also during its revolution, once it will become closest to the Earth, once it will become what? Farthest to the Earth. So exact similar diagram we can draw here to have comparative understanding. So this is Earth here now at the center, and then Moon. Moon is orbiting around the Earth. So this is the Moon, and one position we can mark here. So similar terms is used here. So when the Moon is closest, let us suppose this is the closest distance. When Moon is closest to the Earth, it is called as perigee. And when Moon is farthest from the Earth, it is referred as apogee. So we have perigee and apogee. Perigee and apogee. Right. Now, will the perigee apogee occur once a year or multiple times in a year? Between Earth and Sun, what we are seeing? Once you will have aphelion, once in the year you will have perihelion. But in the case of Moon and Earth system, what will you experience? Multiple time or one time? Multiple times, because you know that Moon is orbiting around the Earth, completing one revolution in very short period of time. How much? Roughly 29 days as such. So that's why in a single month you can have this apogee and perigee. Okay, every month you'll have this kind of position. So we do not have any particular date that you can put here, and that what date will have apogee, what date we have perigee. It happens multiple times as such. Okay, but this is the similar kind of system. Apogee, perigee here. Easier to remember because why we are calling it G? G comes from where? Geo. What is at the center here? Earth. Okay, Geo. That's why perigee, peripheral to G. That means near to the G. And then you have apogee. That means on the farther extreme of the Geo. That is Earth. Why we are calling it helion? Because the Greek term for the Sun is what? Helios. Okay. So in geography, we will see most of the terminologies come from Latin or Greek language. So because of that, Sun is used as this term used for Sun is Helios. We call it as perihelion and aphelion. So that's the simple to remember. Perigee, apogee, perihelion, aphelion. Right? Understood? Clear? So that is the point. Now there is one other effect of revolution that we experience, and that is the occurrence of season on the earth. Okay, we know that on the earth we have four type of season. What is the name of the season? Summer, winter, spring and autumn. Okay, so all these four seasons that we experience, it is because of what factor? Because of revolution of earth around the sun. So a statement we can write better, that due to earth's revolution, due to earth's revolution around the sun, earth's revolution around the sun on a tilted axis, and this also we will discuss, on a tilted axis, due to earth's revolution around the sun on a tilted axis, occurrence of season is observed on the earth. The occurrence of season is observed on the earth. Right. So it is because of the revolution of earth, and not only the revolution of earth, but on what axis earth is revolving around the sun? The axis is kind of tilted. Okay. So let us first understand the term. What do we mean by tilted axis? So suppose that this is the earth, right? And we have seen that earth is doing two motion. First motion is what? Rotation. So earth is rotating. So let us suppose this is the axis. Yeah, this is the axis of earth's rotation. Now why we are calling it tilted? Because earth is also revolving. So earth is revolving around sun. So this path in which earth revolves around the sun is referred by what term? It is called as orbital plane. So like for example, this is the plane. Earth is continuously moving in this plane around the sun as such. So this is the orbital plane, and this is what we are describing as the axis of rotation. Now what we observe is that axis of rotation is not perpendicular to this orbital plane of earth. Rather it is kind of tilted. So how do we define the tilt? So now we imagine that we draw a perpendicular. Perpendicular to what? Perpendicular to the orbital plane. What is orbital plane? The plane in which earth is revolving around the sun. So this is perpendicular, that means obvious it is 90 degree. And then if you measure this particular angle between what? Perpendicular and the axis of rotation. So how much is this angle? This is about 23.5 degrees. Thus we can say that the axial tilt of earth, what is the value of axial tilt of earth? So it is 23.5 degrees. So earth's axis is tilted by 23.5 degrees from the perpendicular drawn to the orbital plane of the earth. Yeah, that is how geographically tilt of the earth or axial tilt of the earth is defined. So very simple diagram, you can quickly draw it. Orbital plane, perpendicular and the axis of rotation. Right. So this axial tilt play a very important role. If Earth's axis was not tilted, we would not have experienced seasons, even if the Earth was rotating around Sun as such. Okay. So seasonal occurrences largely because of this phenomena, the tilt of the Earth's axis, okay, as shown on the orbital plane. Now the tilt, the northern part of this axis, where it passes through, what is that place called as? North Pole. And this southern part where it passes through is referred as South Pole. Okay. So the North Pole and South Pole, geographical North and South Pole that we determines, that is on the basis of from where the axis of rotation passes through. So North Pole, South Pole. Now very interesting to observe that how this axial tilt causes the seasonal occurrences. So we can give the heading occurrence of season. Occurrence of season. So imagine at the center we have the sun. Sun is there, and Earth is revolving around the sun as we have seen. So suppose that now Earth is at this particular place. This is the Earth, and this is the axis of rotation as we have seen. So this is the North Pole, right? This is the South Pole, and if I draw this line bisecting the Earth, what is that line called as? Yeah, the line basically it is a kind of circle, right? Great circle that you have divides Earth into two equal hemisphere, northern hemisphere and southern hemisphere. So to the north you have northern hemisphere, south you have southern hemisphere. North pole, south pole is clearly observed. Now if you look from the sun, the light is coming like this. Now which pole? Forget it. Simply imagine that light is coming from the sun itself. So what we see that northern pole is what? Tilted away from the sun, and southern pole is what? Tilted toward the sun. That means you can say the southern hemisphere is receiving more sunlight. Northern hemisphere is receiving what? Relatively less sunlight, because the entire northern hemisphere is tilted kind of away from the sun, and it is tilted like this, and Earth is carrying out rotation. So no matter how much Earth rotates, northern hemisphere will always receive relatively less amount of sunlight. Yes or no? Right. So we can say that from the perspective of northern hemisphere, which season should we experience here? Winter, because the availability of sunlight, amount of sunlight received is less. So winter, and the position of this particular position of Earth with reference to sun is referred as what? Solstice. So when the Earth and sun are oriented like this, northern hemisphere is tilted away and the southern hemisphere is tilted toward, we call it as a winter solstice, which is observed on which date? What date? Right, December, 22nd of December. So winter solstice, the first season and the position of Earth with reference to the sun. Understood or not? Winter solstice because of what? Northern hemisphere is receiving less sunlight. But suppose you ask someone in the southern hemisphere, what season will he experience? Summer. Okay. So seasons depends on which hemisphere of Earth you are in. If you are in India, in the December you will experience winter. But you take a flight and go to Australia, what will you experience there? Same time, same days, summer. Right. So that is because of this reason. So winter here, okay, summer in the southern hemisphere. Then sun moves, Earth moves, and after 3 months, Earth reaches somewhere at this place. Okay? Earth is revolving like this. So Earth reaches here at this place. Now in this case, the tilt does not have any role to play, because tilt is what? Like this and this. And now here sun is like this. So no matter how much is tilt, half of the Earth will receive sunlight for 12 hours and next half would receive sunlight for the next 12 hours as such. So can we say that both hemispheres here are receiving what? Equal amount of sunlight. That's why if you go from December and by the time of, let us suppose 21st of March, okay, because you have equal distribution of sunlight here in both hemispheres, the position is referred by what term? Equinox. And after winter, which season comes? which season? Spring, right? So what we'll call it? Spring equinox. So 21st of March. 21st of March, the earth and sun are oriented like this. So this is we are showing because it is two dimension. If you imagine that earth would be where? Behind the sun. Okay, if you're looking from this side, it's not up, it is kind of on the other side of the board. So spring equinox. Again, after 3 months, earth would come here, exactly on the opposite side. Tilt is like this. Okay, this is the north pole, this is the south pole. Again, which hemisphere now will receive more sunlight? Right, because which hemisphere is tilted towards the sun? Northern hemisphere. Southern hemisphere is tilted how? Away from the sun. That means we can say at this particular position, from the northern hemisphere perspective, what will you experience? Summer solstice. And on what day is it experienced? 21st of June. So 21st of June, the position of earth can be explained like this. It is referred as summer solstice. This is also longest day. It just has passed recently last month itself. So 21st of June is also considered as what? Longest day of the year. For which hemisphere? Northern hemisphere. Acha, that means 22nd of December, we can say from the northern hemisphere perspective will be what? Longest night of the year. So this also is important to keep in mind. 21st of June is considered as the longest day of the year, and 22nd of December is considered as the longest night of the year. And then finally earth reaches here. Okay, this is exact opposite to the spring equinox. Again, will tilt have any role to play here? No, because tilt is like this, okay, and sun and earth are like that. So half this we can say that both of the hemisphere will receive almost equal amount of sunlight. So here we have a spring, here we have summer. Which season will come after the summer season? We have between summer and winter. Season is referred as autumn. So autumn, again equal distribution. Thus what term we will use? Equinox. Autumn equinox observed around 23rd of September. 23rd of September. So these are the 4 seasons that we can experience on the earth simply because of the revolution of earth as well as the tilted axis of orbit. Now can you think and see that why if there were no tilt, season would not have occurred? Because imagine that no tilt means what is the condition? The plane, the particular axis is perpendicular to the orbital plane. So if it is like this and earth is like this, no matter wherever earth is, what is going on? 12 hours this hemisphere receives same amount of sunlight, next 12 hours other hemisphere. So always you will have equal distribution light on both hemisphere. If you have equal distribution, that means there is no change in the sunlight. No change in sunlight means no change in season as such. That's why not only the revolution but the revolution on tilted axis. Very, very important point. This is from where in UPSC they have asked questions also in prelims examination. And the question was that which of these causes seasons on the earth? So rotation of earth, revolution of earth, revolution on a tilted axis, none of the above like that. What is the correct answer? Revolution of earth on the tilted axis of orbit. So that's the point. So that is about the seasons. So revolution we have to understand in 2 ways. One is perihelion and aphelion we have studied, and second extent this part of revolution is the occurrence of winter, summer, autumn and spring. Clear everyone? Understood up to here? Yes, that is the motion of the earth. Rotation, revolution. Now, you consider all the 3 together. So we have sun here and somewhere here, let us suppose you have the earth. So Earth is orbiting around the sun. And where is Moon? Moon is carrying out its own revolution around the Earth as such. So based on this, 4 distinct positions of moons we can mark. So let us suppose this is M1, Moon is here, then Moon rotates, goes to M2, then Moon rotates, it goes to M3, and then further it rotates and goes to M4. Okay, so all these three celestial bodies, now we can consider them together. The Sun, Moon and Earth system. So M1, M2, M3, M4. Now if I ask you, all of you must have experienced full moon and what else do we have? New moon. So in full moon, the entire face of moon is visible to you. Full face of moon is visible to you. In new moon, what happens? Moon is not visible at all. So if we look at this particular picture, which of these positions of moon will mark full moon? Which of these will mark new moon? Think for a few seconds, then answer. M1, M2, M3, M4. 4 positions we have marked. Which of these are this full moon and which of this is new moon? M1 is Acha, and full moon? M3. Right. Anyone else? Any other answer? M1 is full moon, M3 is new moon. You are saying the exact opposite, reverse. Anyone else? How many of you think M1 is full moon? Please raise your hands. M1 full moon. You just change? No. Okay, so M1 full moon. How many of you think M1 is new moon? And then all others cannot think. So M1 is what kind of moon? It is new moon. Okay, so why new moon? Does moon have its own light? No. So why are we able to see the moon? Because moon's sunlight falls on the moon, it is reflected and then it comes to the earth as such. So in this case, what is going on? Imagine that light from sun comes. Light from the sun is coming. And after it is reflecting. Which direction will the sunlight reflect? Laws of reflection you would have studied in the class 5, 6, I think somewhere. That when light is incident on any surface, it reflects in which direction? Same direction. So all the light that is falling on the moon surface will be reflected in which direction? Toward the earth or away from the earth? Away from the earth. So from the earth, if you're looking, which face of moon is toward you? This face. Is this face receiving any kind of light? No. That's why, can you see the moon? No. That's why, what kind of moon it is? New moon. Okay, moon is not visible. But if moon is on M3, what happens? Light comes from there, from sun. It strikes which surface? This surface. From here, it comes to strike which surface? This surface. And then in which direction it is reflected? Toward the earth. So when you're looking from the earth, what is visible? This entire face of moon is visible to you. Full face of moon is visible to you. One part of the hemisphere, you can say. Right? A sphere actually. So that means M3 becomes which kind of moon? Becomes full moon. Right? So M1 is new moon. M3 here represents the full moon. So that is the correct answer. What about M2 and M4? What kind of face will be visible here? Half. Okay, only half face. This is your half moon. Half moon geographically is referred as quadrature moon. Quadrature moon. Or quarter also is a term that we use. Quarter. Quadrature or quarter. Done. Right. Now, moon, we can say it is changing its shape between position M1, M2, M3 and M4. Different phase of moon, the size of moon, shape of moon will be visible to you in the sky. So, the names of these phases also is important to remember. So, imagine that we are starting from M1. M1, after M1, moon is going toward which phase? It is going toward M2 phase. So, first we can write M1 to M2 we can show. When moon is starting its journey from the new moon and going toward the first quarter. So, this particular phase of journey between M1 to M2 is referred by the term waxing crescent phase. Waxing crescent phase. The entire journey of moon between M1 to M2 is referred as waxing crescent phase. Crescent means what shape of moon is called as crescent? When moon is something like this. Okay, so this is what you call as crescent. Waxing crescent phase. Then when moon moves between M2 to M3 phase, it is referred as waxing gibbous phase. Waxing gibbous. Right, M2 to M3 called as waxing gibbous phase. Then M3 to M4, it is called as waning gibbous. Waning gibbous. And M4 to M1, it is referred as waning crescent. Waning crescent. Right. So, waxing crescent, waxing gibbous, waning crescent. These are the four phases that we can describe the moon's journey in. And new moon, full moon, okay, then half moon, that is quarter moon that we have. So, sometime because this is the first part of quarter, what is referred as? Which kind of quarter? This is the first quarter. Then full moon. Then this is which part of the quarter? Third quarter. And then we have the new moon. Understood? So now you understand that why do we see the change in the phases of moon? Because what happened? The moon's position relative to the earth and sun keeps on changing because moon is rapidly revolving around the earth as such, 29 days interval. That's why we are able to see every 14-15 days we have the, like for example, 29 days, that means roughly 7, right? So after every 14 days, 15 days, what will have? Full moon. Again after next 14 days, what will have? New moon. Okay, so full moon, new moon every 14-15 days. So that is because of the fast motion of moon around the earth. Clear? So these are what we have to study in which part? Which motion of the earth? Revolution of the earth and something. So rotation of earth, revolution of earth. That is the motion of earth we have studied. Now next we can write. Next we have to understand about the latitudes and longitudes of the earth. Yeah, that is the division of the earth. Next topic is latitude and longitudes of the earth. Latitudes and longitudes of the earth. So first we can define the term. What do we mean by a term? Latitude. Definition. Latitude. Latitude. It is the angular distance. It is the angular distance of a place. Angular distance of the place measured from angular distance of place Acha, place on the earth's surface, we can write like this. Place on the earth's surface, measured from, we can later relate. It is the angular distance of place on the earth's surface. On the earth's surface, measured from the center of earth. Angular distance of place from the earth's surface, measured from the center of the earth. Measured from the center of the earth. Right, so imagine this is the earth. We have to understand how actually latitudes are drawn. All of you must have seen, like if you look at the map of the world, what kind of lines are latitudes? These kind of basically circles that you draw all the way from equator to pole, or we can say from south pole to north pole. So different sizes of circle. So this is how we represent the latitude. How exactly is latitude drawn? As a latitude, is it a real line or imaginary line? Okay, there is no such physical line that exists on the earth. We have drawn it for our own convenience, okay, for our own purposes. So how is latitude drawn? Now imagine this is the entire sphere, spherical kind of object, that is earth, and what you do, you cut it. Imagine you cut the earth into two equal parts as such. So what will you get? Two hemisphere. This is first hemisphere, this is the second hemisphere. So now let us take any one of the hemisphere. Hemisphere will look something like this. If you have cut the earth, this is the face. Right? This is how hemisphere will look like. And that means this place here. This face will be of what shape? Circular. Okay, imagine cutting a watermelon. When you cut the watermelon, what kind of face it has? Circular face. And then you have a hemispherical body. So circle, that means here we can find out what? Center of the circle. And this is the center. Now we can draw radiuses at various different angles. So take the center, you draw what? Straight line. How much angle is it? If you are drawing a parallel line, how much angle is it? 0 degree. Okay, so this is 0 degree. You take this as a reference point where? On the earth surface. Okay, imagine that it is watermelon. You are moving a knife from the center of watermelon to the edge. Okay, and then you make point here. Take that point as a reference and draw a line all on the surface. Right. So you take that as a reference and draw a line all around on the surface. This becomes what? 0 degree latitude on the surface. Now you can imagine, you draw same exercise, you draw lines at different angles. So 10 degree, 20 degree, 30 degree. Up to where you can draw? This is the, how much? 90 degree. So you take every line as a reference and keep drawing the circle. So 30 degree, 60 degree. This will be what? 90 degree. So this is how we can represent. Now this is, we are going in which direction? You start from here in the northern direction. So all the latitudes here we will represent by what term? Like this. So 0 degree is simple. Okay, it is both in north and south, common. But apart from that, all of the latitudes can be represented in the north and south form. So this is 10 degree north, 30 degree, 60 degree, 90 degree. Same thing you can do in the south. You draw a radius at 30 degree, 60 degree, 90 degree. And you draw a line on the entire surface. This becomes what? 30 degrees south, 60 degrees south, and here what do we have? 90 degree south as such. Understand? So one hemisphere you have drawn the line. Now imagine you doing the same thing for which hemisphere? The other part of the hemisphere. And then you merge them all together. When you merge them all together, this part will disappear because now it is inside. What part would be seen on the surface? All these lines and circles that you have on the surface. So each of these lines and circles we are representing by what term? Latitudes. Okay, between 0 to 90 in the north, 0 to 90 in the south. Understood? That's why how latitude we have defined? It is the distance, angular distance of what? Of any place on the earth. Where we are measuring this angular distance from? From the center of the earth. Okay, so that's why sometimes confusion arises, because when you look at the earth, you see only lines on the surface. So how center comes in picture is not understandable. So it is because the way how we define latitudes. Now when you talk about the latitudes, some important latitudes we can show on the globe. So, this clear up to here? We not have drawn it, it's simply for understanding purposes how latitudes are drawn. So this is the Earth. So major latitudes. The first is which divide the Earth into two equal half. What is this latitude called as? Equator. So 0 degree. The angular distance is 0 degree from the center, and the latitudinal line is called as equator. And also because now if you look, which is the widest part of the Earth? This part. If you go to the north or south of the equator, what is going on? Earth is becoming narrower. So every circle of latitudes that you draw, that definitely will be what? Smaller than this one. That means if you look at all the latitudinal circle, which is the largest circle, biggest circle? Circle of equator. That's why equatorial region or equator latitude is also referred by the term, what term? Great circle. Okay, because it is the greatest circle, largest circle that you can draw on the Earth. So we can now start from here. 0 degree, important latitude. So first important is 0 degree. 0 degree, that is equator. Right. Other important latitude is at the angle of 23.5 degrees, both in the north and in the south. 23.5 degrees north, 23.5 degrees south. What is the 23.5 degrees south line is referred as? Tropic of Cancer or Capricorn. Right. In the south, it is referred as Tropic of Capricorn. 23.5 degrees north, what do you call it as? Tropic of Cancer. The Tropic of Capricorn, Tropic of Cancer. Then we go further south, we draw other latitude, one at 66.5 degrees north and other at 66.5 degrees south. So this is referred as Antarctic Circle. Antarctic Circle. This is referred as Arctic Circle. Yeah, Arctic and Antarctic. Right? That's how it is named. Arctic. And now there is a dispute, but many scholars believe that the name comes from Arctos. Arctos means bear. So polar bear. Where will you find polar bear on which pole? North Pole or South Pole? North Pole. Do we have polar bears in the southern pole? No. Polar bear only is found where? In the Arctic region. So Arctic, anti-Arctic, that is the area that is free of bear. Yeah. That's how we can remember. So Arctic, Antarctic. So that is the thing. And then last is point that is 90 degree north, referred as North Pole, and 90 degrees south, referred as South Pole. So equator, Tropic of Cancer, Arctic Circle, Tropic of Capricorn, Antarctic Circle. Done? Clear? So that is the overall poles, this important latitudes. Now based on this latitude, we divide Earth into several heat zones. So first zone is this one. Which zone? Between Tropic of Cancer to Tropic of Capricorn. This zone receives highest amount of sunlight, insolation we can say, because it is no matter whether the pole is oriented in this direction or this direction. This part we can say will always receive kind of higher amount of sunlight, stronger sunlight as such. So that's why this entire zone between Cancer and Capricorn is referred as torrid zone. Torrid zone, heat zone. Then you have the area between 23.5 degrees north to 66.5 degrees north. This one and this one. So this is the second heat zone. This is referred as temperate zone. Temperature is slightly lesser than the tropical areas. Temperate zone. This side also temperate zone. And then the last one is between 66.5 to 90 degrees in north as well as in south. This is referred as which zone? Frigid zone, frozen area, frigid. Frigid zone. So total Earth can be divided into 3 heat zones as shown here. The tropical, that is torrid zone, temperate zone and frigid zone. And when you move from torrid zone via temperate zone to frigid zone, what will you observe? What happens to temperature? Temperature continuously decreases. So maximum temperature you will find where? Equator. And from equator toward poles, temperature keeps on reducing. And at poles, what would you experience? The minimum temperature on the Earth's surface as such. That is this distribution of heat. We'll discuss that in atmosphere also, why it happens, why temperature reduces and all. For now, we can simply remember the heat zones and the change in the temperature, variation in temperature. Understood this point, right? So equator, tropics and Arctic Circle, Antarctic Circle and all that. Now a homework I am giving you, because you also have to start looking at atlas. All of you have atlas. If not, then you should buy. Atlas is very important part of your geography preparation. So atlas, it's not that you have to study map and all that after the end of syllabus and all that. You have to do it along with the classes itself whenever you're talking about any particular area. So what you should do, you should go on the world map. You'll find in world map all these 3 lines will be given. Which lines? Equator, Tropic of Cancer, Tropic of Capricorn. Okay, we have to skip Arctic and Antarctic Circle, not important. So equator, Tropic of Cancer, Tropic Capricorn. What you have to do? You have to list the name of what? Countries, okay, that are located along these lines. Okay, so that also will give you idea how to look at the atlas, okay, how to extract information from the atlas. So try to do this by yourself. Countries, name of countries through which any of the 3 line passes through: equator, Tropic of Cancer and Tropic of Capricorn. So that is about the latitude. The other line that we draw on the earth is longitude. So next we can write is longitude. Longitude. So we can first define the longitudes. Longitudes. What are longitudes? So it is referred as, right, definition of longitude. It is referred as the angular distance, of a place on the earth, angular distance of a place on the earth measured from prime meridian, measured from the prime meridian. Right. So what is prime meridian? That also is drawn in a similar way how we have drawn the longitude, but the way how we will cut the earth is slightly different. So in the last case, for drawing of latitude, we had the earth, and how did we cut it? By like vertical we can say. Okay, vertically we cut this into half. For longitudes, drawing of longitude, imagine that now you are cutting earth in which way? Horizontally. Okay, so again you have northern part of the hemisphere and the southern part of the hemisphere. So let us imagine now we have the northern hemisphere. Again the face will be kind of which shape? Circular shape. So something like this. Again what you do? Same thing. You find the center of the circle. From center you draw a parallel line. How much degree is it? 0 degree. You take this 0 degree as a reference and now you connect this point with which region? North pole. Right. You draw other angle, anything 10 degree. Connected to what? North pole. Other angle connected to what? North pole. Right. North pole. So this will be how many degrees? 0 degree. And then you are doing 10 degree, 20 degree, 30 degree. Yeah. So this we can say 10 degree. This let us suppose is 30 degree. This is 90 degrees. Okay, because this is perpendicular to this particular point. So 90 degree. And now if you look, you are going in which direction? West direction or east direction? What is it? West or east? West. So all of these longitude will also refer as what? 10 degree west, 30 degree west, 90 degree west and all that. And now in this case, because you're cutting like this, you further go on the other side of the earth and you keep drawing the lines. Okay, now what are you doing? 100 degree. What you can say? 130 degree, 150 degree. And finally this will be what? If this is 0 degree, the exact diametrically opposite line will be of how many angle? 180 degree as such. This will become an 180 degree. All of this is also which kind of longitude? Western longitude. So you make longitude all the way from 0 degree up to how many degrees? 180 degree, covering the entire one part of the hemisphere as such. Can we do the same exercise on other side or not? Right, you take this angle, this angle, this angle, here, 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 and again connect it all to which place? Connecting it to northern pole. Okay, imagine the back side also it is connected to northern pole as such. This we will call as what? This is also 10 degree, 30 degrees, 90 degree. But now if you look, this is a 0 degree. From 0 degree if you are moving in which direction? Eastward direction. So all of these longitude will refer by what term? East. Okay, further same 100 degree east, 130 degree east, 150 degree east. Achha, 180 degree line will be same line or two different line? Same. Two lines will be same. One will be 0 degree common, other will be what? 180 degree common. And between 0 to 180, you'll have two set of two different angle, 5, 10, 20, 30. It will be east also, it will be west also. So this is the way how you're drawing longitude in the upper part. You can imagine that we have the lower part of the hemisphere. You do the same thing, but there you connect all the lines with which pole? South pole. So you have similar kind of lines and angles connecting the south pole. And then what you do? Bring them all together. When you bring them all together, this part will disappear. It goes inside. And on the earth, what would you see? Simply a line coming from north pole, terminating at which pole? South pole. The entire line will be called by what name? 0 degree line, right? Prime meridian we call it. Similarly, you will have 10 degree east starting from north pole, terminating at south pole. 30 degree east starting from north pole, terminating at south pole. So this entire distribution of lines is what we are calling as. This is referred as longitude. And the line 0 degree is referred by what name? Prime meridian. So this we can draw. The longitude becomes quite little complex to understand. So how longitudes are drawn? Basic diagram we can make. And actually, when you merge both the hemispheres, lines on the Earth's surface would resemble something like this, all the way from 0 to 180 degree. So if I ask you how many number of longitudes you will have on the Earth's surface? Total, how many number of longitudes we have? 360. Okay, so number of longitude 360. Now we have to understand the use of longitude. Why or where do we use longitude? What is the purpose it serves for us? One purpose is, along with latitude, it is helpful in identifying a particular location on the Earth. Okay, you express location in the form of what system? Coordinate system. Coordinate is basically nothing but the values of latitude and longitude. Okay, because if you imagine that now you draw latitudes also on the Earth. So entire Earth basically looks like kind of grid system, right? So if you want to know where a particular person is located, okay, let's suppose I am saying that currently my location is 0 degree latitude and 0 degree longitude. Will there be multiple point or one point? That will be one point. 0 degree latitude, that is this line. 0 degree longitude, this is this line. So where both of them are intersecting, that will become 0 degree latitude, 0 degree longitude as such. Okay, you further divide them also into multiple seconds and minutes and seconds also to make it more smaller. But that is the point. Similarly, someone says that I am 0 degree latitude, but I am at 10 degree of latitude. That means he is at which location? This particular location. So we can write the statement: the latitudes and longitudes, the latitudes, the latitudes and longitudes together, latitudes and longitude together are used for, latitudes and longitude together are used for identifying the exact location, used for identifying the exact location of a place on the Earth, exact location of a place on the Earth. Right. Also, one thing you will see by observing this particular this diagram, that these are the latitudes. If you measure the distances between two latitudes, no matter wherever you are measuring them, will that distance be same or different? Same, because they are parallel lines. But if you measure the distances between two longitude, it will change. Right? Near equator, the distance between two longitude will be widest, and toward the pole, what happens? It keep on decreasing. At poles, what will happen? It will become minimal as such. Okay, so this is simple observation you can keep in mind. Then other is, that is the one purpose. Second purpose, longitude also serve the purpose, which is the most important one, in the calculation of time. Okay, so we can write that one. Longitude also is used for calculation of time. Calculation of time. Now, how is longitude used in calculation of time? So first, if someone asks you how or why does time change, what is the reason? Why we have different time? Rotation of Earth. Rotation of Earth causes what? Change in the relative position of Sun with reference to a particular place on the Earth. So once Earth completes a rotation, complete rotation, how much time changes by? We have just discussed one complete rotation takes how much time? 24 hours. So we can say that in one complete rotation time changes by 24 hours. And in one complete rotation, how many degrees Earth is rotating by? 360 degrees. So what we can say? For 360 degree of rotation, when Earth completes 360 degree of rotation, time changes by 24 hours. Okay, so that we can write first of all. that for 360 degree of rotation, 360 degree of rotation, the time will change by 24 hours. For 360 degree of rotation, time changes by 24 hours. That means if I say for every 1 degree of rotation, how much will time change by? How much it will be? 15 minutes, right? Because 24, you convert that into the minutes, right? And then divide it. 360 degree of rotation, time changes by 24 hours. Okay, also a simple, in 1 hour, that means how much Earth is rotating by? How much? Okay, I don't think it should be 15 minutes, no? See, for 360 degree of rotation, how much time it takes? 24 hours. So in 1 hour, how much it is rotating by? 15 degrees, right? So in 1 hour, it is rotating by 15 degree. When 15 degree means equal to how many minutes? 60 minutes. So 1 degree equal to how many minutes? 4 minutes actually, right? So for every 1 degree, 15 minutes will be in 1 hour, not 1 degree. So degree of rotation, time changes by 4 minutes. Clear, not understand? Yeah, simple calculation, 360 24, and that's how it will. So for every degree of rotation, it will vary by how many minutes? 4 minutes. And we have divided Earth into how many number of longitudes? 360. So you can also say that for every degree change of longitude, how much will time vary by? 4 minutes. So if you are at 0 degree and someone asks you what will time at 1 degree of longitude, it will be 4 minutes different. Okay, addition, subtraction we'll discuss later, but we know that there will be a difference of 4 minutes as such. So 1 degree, 4 minutes. Now question comes that we have divided longitude in two ways. One is the eastern longitude, other is the western longitude. Both can have same values. So how will time change between east and west? If at a particular place you know the time and you are calculating time to the east of that place, will you add the difference or subtract the difference? Okay, let us understand by example, easier it will be. Okay, so let us imagine we are talking about which longitude? 0 degree. That we are also referring by what term? Prime meridian. Now I am saying that right now at prime meridian, what is the time? 12 noon. Now someone asks you that my friend is at 10 degree east, and other person said that my friend is at where? Sorry, this is 10 degree west, and other person says that my friend is where? At 10 degree east. So what should be time here and what should be time here? Simple. Currently it is 12 noon at prime meridian. Achha, what is the time at prime meridian referred as? GMT, right? Very good. So whatever time is at prime meridian, that particular time is referred as GMT, that is Greenwich Mean Time. And you are now asked that if this is the time at prime meridian, what should be the time at 10 degree west and what should be the local time at 10 degree east? So what should be your answer? Yeah. 10 degree west, first tell me, what should be time? First of all, difference let us calculate. So every degree of rotation time will vary by 4 minutes. What is the difference here? 10 degree. So we know that at both places time will differ by 40 minutes. So how to decide whether to add this 40 minute or subtract the 40 minute? What is the region? So basically, for example, Earth is rotating from east to west or west to east. West to east. Okay, Earth is rotating from west to east. Sun is moving from east to west. So eastern places will always be ahead. Western places will always be lagging behind. Why? Because sun already has passed over the eastern places, and now sun still has to move and reach the western places. Right? So eastern places are ahead, western places are lagging behind. So if you are calculating time to the east, what do you have to do? Add. If you are calculating time to the west, what do you have to do? subtract. That means at 10 degree west, what should be the time? 11:40, 40 or how much? 20, right? 11:20 am. And at 10 degree east, what should be time? 12:40. 12:40 p.m. Okay, so 11:20 a.m. and 12:40 p.m. This should be the time if the current time at the prime meridian, that is Greenwich Mean Time, is 12 noon. So this simple rule you have to keep in mind. If you're calculating time to the east of any place, you have to add the difference. If you're calculating time to the west of any place, you have to subtract the difference. That is because of rotation, direction of rotation of Earth. If Earth was rotating in opposite direction, then we would have done reverse. Okay, east we would have then subtracted, west we would have added. Okay, so direction of Earth. Imagine, right? Because at 12 in PM in GMT, what kind of time you have? Noon. When we can say it is noon, when sun is directly overhead. And which direction sun is coming from? East. While crossing from east, now it has reached GMT. That means noon already has taken place everywhere in the GMT, in the eastern direction. And western direction still have not seen overhead sun. That means noon is still will take place in the future. Okay, that also is how we can understand. So add and subtract. Now we can take one real example, means one actual example from UPSC prelims question that was asked on the same concept to understand it better. So you can write a question based on exact same concept. UPSC prelims. So question is, if it is 9 am as per IST. What is IST? Indian Standard Time. If it is 9 am as per Indian Standard Time, let us say Monday also is given. 9 am Monday as per Indian Standard Time. What is the local time? Yeah, that is the question. What is the local time? Local time in Shillong. Where is Shillong located? Which state? Meghalaya. So local time in Shillong at 92 degrees. Shillong is located at the latitude of 92 degree east. That was the question. If it is 9 am Monday as per Indian Standard Time, what is the local time? What is the local time in Shillong that is situated at 92 degree east? Right. So how would you calculate this particular this question or answer? What is given here? Indian Standard Time. That means they have not given you the longitude used for calculation of standard time, because you are expected to know it. Okay, once you have studied in geography and all. So can anyone tell me what is the longitude used for calculation of IST? 82.5 degrees east. Right. So now you should be able to calculate. The IST is calculated on the basis of 82.5 degree east of longitude. So basically this question becomes what? The time is given at this longitude and you are expected to calculate time at this particular longitude. Okay, so should be easy. Nine 9:38 AM or PM? AM. Right. Anyone else? Any other answer if you have? Right, got it? What is your answer? 9:38, right? Simple. How do you calculate? So you are given time at which longitude? 82.5 east. And where you are expected? 92 east. So what is the first thing you have to do? Take the difference. So 92 minus 82.5. Why we have to take the difference? Because remember, what is the basis on which we are calculating the time? Every 1 degree change in longitude causes 4 minutes of difference. So you have to understand how many degree of difference in longitude is here. So how much is difference? 9.5. So there is a difference of 9.5 degree. For every degree of change, 4 minutes. So 9.5 degrees means how much of difference you will have? 38 minutes. Now add or subtract? Add, because if 82.5 degree east is the time, you are going to 92. That means you are moving further in the which direction? Eastern direction. So in eastern direction, what you have to do? You have to add the difference. That's why 9:38 AMS section. Clear? Right? Because 0 degree, 0, 10, 20, 30, 40, 50, 60, 70, 80 and then 90. So what you are doing? You are going further toward east all the way up to 180. If the question is same and just one change is made here, that this is time at IST, what should be the local time at what longitude? Now 92 degree west. Okay, so calculate it. Same question. Okay, think and calculate. 9 a.m. as per Indian Standard Time, Monday. What should be the time at 92 degree west? If you visualize the longitude, you will be able to calculate. No, 822 is not the right answer. 818. You have to visualize the longitude. Without it, you will not be able to find the right answer. 9:38 p.m. 9 p.m. Who is saying 9 p.m.? How did you calculate? Exact opposite. Exact opposite of what? No, this is not exact. This is here. 9 a.m. is time where? 82.5 degree east. Okay, and then you have to calculate time at 92 degree west. 8:18 what? 8:18 a.m. It's not the right answer. Anyone? Right, see what is the what is the time at 82.5 degree east? What is the time? 9 a.m. on Monday. Where are you calculating time? 92 degree west. Now what is the mistake you're doing? You're imagining that 92 degree west will be just 8.5 degree away from the 82.5 degree east. Is that the case? No, right, yes. So what you have to do? I said you visualize. So imagine this is your prime meridian. So 82.5 degree east will be where? Somewhere in this side, eastern side. This is your 82.5 degree east. 92 degree west will be where? On the opposite side of prime meridian. So this is 92 degree west. So the difference in angle is 8.5 or more. What is the difference? You come from 82.5 to 0, that is 82.5 plus further you going how much? 92. So exact difference will be how much? 92 plus 82.5, that is 174.5 degrees. So difference in longitude. Hello. Yeah, Sunday 9:22 p.m. 9:22 p.m. I think that should be the right answer. Okay, so 174.5 into 4. Okay, we'll check it. I think it should be right answer. So how much is the difference in minutes? 698, right? 698 minutes. That means how many hours? 11 hours and how many minutes? 38 minutes. Yes. Okay, so 11 hours 38 minutes. And you are moving to the west. That means what would you do? Add or subtract? Subtract. So time given at IST is 9 a.m. Subtract 9 a.m. minus 11 hour 38 minutes. What should be the time? If you go 12 hours back, it will be 9 p.m. But you are going only 11 hours 38 minutes back. What should be the time? 9:22 p.m. Same day or different day? Different day. If it is Monday here, this 9:22 p.m. will be what? Right, on the Sunday as such. Right. So that is the time. So that was a mistake. You have to visualize where the longitudes are located. Then it is easier. So yes, the correct answer is 9:22 p.m. on the Sunday. Understood the concept, right? So now I think you should be able to calculate time everywhere. You just imagine the longitudinal orientation. So now if you look, every time on every place on the earth, time is calculated on the basis of which time? Greenwich Mean Time. So if you calculate time of India, if London has suppose 12 noon, in India what should be the local time? The last question we can do like this. Right, simple, because what is the longitudinal difference? 82.5 degree. 82.5 into 4. Okay, that will be how many minutes? 330 minutes. 330 minutes means how many hours? 5 hours 30 minutes. We are moving to the east. That means what we have to do? Add. So 12 hour, that is 12 noon plus 5:30. That means what should be the local time in India? If it is 12 noon in London, because GMT passes through which place? Greenwich is in which city? In the London, UK. So if in London time is 12 noon, in India, what should be the local time? 5:30. Indian Standard Time we can say. Indian Standard Time should be 5:30. So that also we can. Okay, so local time and standard time will be different. In every country, what you do? You decide that which longitude you will take as a reference line to measure time everywhere in the country. So India has only one time zone. No matter wherever you are in India, the actual time will be same everywhere. But actually, if you look at the extent of India, which is the westernmost state of India? In Gujarat. Which is the easternmost state? Arunachal Pradesh. So Arunachal Pradesh, one longitude will be passing here, one longitude will be passing here. If you take this difference, the difference in longitude is almost of how many degrees? 30 degree. For every degree of longitude, time changes by 4 minutes. That means between Gujarat and Arunachal Pradesh, if you actually measure, time should be different by how many hours? Total 2 hours. Okay, so if you are measuring local time everywhere, Arunachal Pradesh will see sunrise 2 hours before than Gujarat, and we will see sunset 2 hours earlier than Gujarat. Okay, but we have decided that we will take the middle longitude of 82.5 and we will use same longitude for calculating time in the India. In the British time, you actually has 2 times. Chai Bagan time it was called in Assam. Okay, they used to calculate the local time based on that. But after independence, we have decided to have a single longitude. Achha, it is not practically possible for countries which suppose is very, very long, right? From one longitude to other longitude differences of many degrees. In that case, can you use the single standard time? No. So which country is example of it? Russia. So you start from the westernmost point of Russia and go to the easternmost point of Russia. So St. Petersburg, you start from, go to Vladivostok. Okay, you have to change your watch how many times? 11 times. Why? Because they are having 11 different time zones, right? So that is because longitudinal extent is extreme. If here you have night, here you will have day. Okay, you cannot have same time anymore. France similarly is the country with which is having the highest number of time zones, right? So that is because France, if you look, size is small or large? Is it a small country or big country? Small country. So why it has so many time zones? 12 time zones or 13 time zones, I think. That is because it has overseas territory. Okay, so in every ocean, France has territory. Indian Ocean, Pacific Ocean, Atlantic Ocean. Okay, that's why such a huge number of, high number of time zones. So that is because of the rotation of Earth, longitudinal differences, and the time variation. Now, one more concept we have to study from related to longitude and time. So there is a line that we have drawn on the Earth that is referred as international date line. So you can give the heading international dateline. International dateline. So we can define it first. What is international dateline? It is an imaginary line. It is an imaginary line used to determine the longitude along which date will change on the earth, right? So this basically is a line that you have drawn on the earth's surface. If you cross the line, what will happen? The date will change. So if you are in 31st of December, okay, you will go into 1st of January, or from 1st of January you will come back to 31st of December as such. So that line, imaginary line we have drawn, is referred as what? International date line. So where exactly it is? So you can later look at the atlas itself. So in the Pacific Ocean, okay, this side if you go, you have Russia, further you have Japan and all that, and this side you will find which country? This is Alaska. Okay. In which country? USA. So between them we have the region that is called as Pacific Ocean, right? Do you know this? So Pacific Ocean. So what we have done, this is also the region where you have the 180 degree of longitude, okay, connecting North Pole. So you start from 180 degree of longitude, but it is not always the straight line. You have to move here and there. So basically you are doing like this. Right. Something like this. So roughly on 180 degree of longitude, but also as we can see, line has multiple curves here and there. Okay. So this line that we have drawn, what we are calling this line as? International date line. Okay. If you look at the continent wise, so North America, if I draw, here will be North America. Okay. Further south, what will have? Central America. Further this side, what you will have? This is the South America. Okay. Here if you go, you have Korea, then China. Further Asia, here you will have countries of such as Japan, Philippines and all that. So basically you have a kind of line, imaginary line, passing through the Pacific Ocean. Roughly you can say the international date line, question can be given, it is perfectly coinciding with the 180 degree of longitude. True or false? That is false, because longitudinal line will always be which kind of line? Straight, perfectly straight line. Is this perfectly a straight line? No. So we can say that ideal roughly coincides with the 180 degree longitude. Okay, so we can draw it like this. Later you can refer to the atlas to have understanding which countries are here and there. This is a rough representation of ideal. So how date changes? Now imagine you are on this side of ideal and you cross this. That means you are crossing from where to where? East to west, right? East to west. You're not talking about hemisphere, talking about simple direction. You're crossing from this side to this side. It means you're coming from east side to west side as such. So when you cross the ideal from east to west, as soon as you cross, what you have to do? You have to add how many hours? 24 hours. 24 hours is equivalent to 1 day. So you have to add 24 hours. On the other hand, if you do reverse, that means you move from where to where? West to east. In that case, what you need to do? Subtract 24 hours. So this is how the date changes. From east to west of the ideal, you add 24 hours. And from west to east, you have to subtract 24 hours. That means if in US you are in which day? Let us suppose Monday. If you cross this and go to Russia, which day you will enter? Tuesday. Yeah, and that's the interesting thing observed, because here you have multiple islands all around this area. Okay, so islands are not more than 25, 30 kilometer, 50 kilometer as such. But even at such a small distance, short distance, this part of island is in the Monday, this part of island is in Tuesday. Okay, so that is because they are near to each other but on the opposite sides of the international date line. That's why they are having two different days or dates as such. And that's the reason also why if you celebrate 1st of January, which countries celebrate 1st of January? Big country wise, you'll find here Australia. Okay, so 1st of January, first Australia, New Zealand, these countries start to celebrate. Then gradually Asia celebrate, India, then Europe will celebrate. And in the last, when all these people are planning to sleep, which countries start celebrating New Year? That is the Alaska people in the US as such. Why? Because you have to go through all the way here, and then only you will have the Tuesday. Understood? Clear? So that is the role or purpose of ideal. Now, two things we have to write in the case of ideal. And before writing this, however, you have to understand the logic behind. Without understanding logic, it will not be interesting. So, see, first question that should come into your mind is that why this? Why we are adding 24 hours or why we are subtracting 24 hours? Okay, what is the logic behind? The logic is simple, based on the longitude itself. So, this is 0 degree, right? And then you are going all the way up to how many degrees? What degrees? 180 degrees, right? (180°). And again we have drawn the eastern longitude all the way up to where? 180 was single line or double line? Single line, right? So if suppose you start from here, journey from here. Now I said you that you are in London, you have to go to 180° of longitude, wherever it is. So you have two ways. One, you will go in which direction? Western direction. Other way is you go by which direction? Eastern direction. In both cases you will be able to reach the ideal. Now imagine what we have seen, that for every 1 degree change of longitude, time changes by how many minutes? 4 minutes. So 0 to 180°, total difference is 180. 180 into 4, how many hours? 720 minutes. How many hours? 720 minute equivalent to how many hours? 12 hours, right? 12 hours. In the west you are going, suppose in the first case you are going in which direction? Western direction. So this 12 hour you will add or subtract? In the west what you do? Subtract. So imagine you start your journey from 12, again 12 noon. So while moving to the west you reach 180°. Now you will say what is the time here? 12 noon minus 12 hour. Now let us suppose this 12 noon is Monday, to make it more clear. So you began your journey at 12 noon Monday. Moving to the west, you reach the ideal, okay, 180° longitude, let us suppose. What you will say is the time now at this place? 12 noon minus 12 hours, 12 midnight. 12 midnight of which day? Monday. Okay, so you will say that it is 12 midnight of Monday. Other friend began journey at the same time, but he decided to move in which direction? East direction. So after crossing total 179 longitude, where he reach again? Same longitude. But now he is going in the eastern direction. Difference will be of same 12 hours because 180° of difference. But now will you add or subtract in east? Add. So now you began your journey from 12 noon, your friend reached here and he will add 12 hours. Now we will say that here also again is 12 midnight. But 12 midnight of which day? Tuesday. So both of you are at the same place. Your friend is saying that I am at 12 midnight Tuesday. You are saying that no, we are at 12 noon, 12 midnight of Monday. Total how much difference you have? 12 midnight Monday to 12 midnight Tuesday. What is the total difference? 24 hours. 24 hours is entire day. Understand? That means it depends on which direction you have moved to. So exactly at this place, this side we are saying that it will be in the Tuesday. This side we are saying that this place will be in Monday. So it is logical. If you cross this line simply, what would happen? You have to adjust your date. Understand? By west you are moving, you are in Monday. As soon as you cross this side, where you are? In Tuesday, 24 hours. If you are coming from this side to this side, what we have seen? What we have to do? Tuesday minus 24 hours, you are where? In the Monday. Okay, so that is how we have decided this, that this should be the line as such. This could be anywhere in the world. Okay, but because 0 degree we have taken as a reference point, that's why the international date line is drawn where? Near the 180 degrees. Understood? This is the logic. Now the question is that if this was true, why we have to do like this? We could have simply drawn a straight line from North Pole to South Pole. So why we are making the international date line kind of curve zigzag in pattern? So the reason is simple. If suppose we have decided to draw it as a straight line, the problem is that here you have countries which are having multiple islands like here. So if you are drawing like this, it is possible that this country has one island here, one island here. What will happen? The same country will have now two different days. Half of the country will be Monday, half of the country will be celebrating Tuesday. How people will not come to work because it's Sunday? How people will reach the office as such? That will cause a lot of administrative inconveniences and all that. Management will become quite difficult. That's why it was decided when the line was being drawn that countries would be asked whether you want to be on the eastern side or whether you want to be on the western side. So, for example, these islands here are closely linked with US Alaska. They said no, we will follow a time that is being followed by US. So what we have to do? We have to drag it like this. Again, we move like this. Here the islands were there. They said that no, we will follow the time of Asia. That is the time in Japan. So you have to curve this again here. So all countries remain in this particular side. So the effort was made so that no single country is facing the problem of two different days and dates. That's why either you are on one side or you are on the other side. So to make that, we have made it kind of zigzag pattern, curve pattern. So we can write these 2 points here about the international date line. The ideal is a zigzag line. The ideal is a zigzag line to ensure that any country lie either to the east, either to the east or west, either to the east or west of the ideal. Either to the east or west of the ideal for administrative convenience. Administrative convenience. Yeah, so which is the first country that you will find here if suppose you are crossing from this side? So a fact we can write, this is a country called as Kiribati. The first country, as soon as you cross the ideal from east to west, Kiribati is the first country. So if actually question is asked which country in the world would celebrate New Year first, what should be the answer? Kiribati. Okay, so Kiribati celebrates New Year first. That is where 1st January is observed first. Kiribati. It's an island country in the Central Pacific. Run, clear? So that is the first statement. Second statement you can write about ideal. Statement is related to this area. You can see this ideal is passing through this narrow terrain, narrow region. So this narrow region is water body or land mass? This area, water body. Okay. If you go to the north of this, where would you enter? Arctic Ocean. If you go to the south, where are you entering? Pacific Ocean. So we can say that this narrow area, okay, is connecting Arctic Ocean and Pacific Ocean. So kind of narrow water body, a small water body connecting to large water bodies. So what is such water bodies referred as? Term that we use for them is strait. So question can be asked that through which strait does ideal pass through? And what should be the answer? This particular strait is called as what? Bering Strait. So second line we can write. The ideal passes through Bering Strait. The ideal passes through Bering Strait. Bering Strait. And in bracket, the definition of straight also you can write if you are not aware about it. What is a straight? That we can define. Straight. A straight is a narrow water channel. A straight is a narrow water channel that connects two large water bodies. A strait is a narrow water channel that connects two large water bodies. Okay, so numerous straits you'll find all across the world because 70% of our Earth's area is covered with water itself. So a lot of straits you'll find. So one of such a strait is Bering Strait, connecting Arctic Ocean, Pacific Ocean, and the international date line passes through it. So that's about the concept of international date line. Date completely changes by 24 hours. That is the other use of which kind of lines? Longitudinal lines. So we have discussed use of latitude, use of longitude, and all that. That is about the division of the Earth. So motion of Earth, division of the Earth. Achha, one more thing. What can we say is the term that we use for the region exact opposite to the strait? One more term we should add here because we're talking about. What is the term? Isthmus. So basically, what is it? A narrow landmass that connects two large land masses. So this also we can draw. Other term is isthmus. A narrow landmass. It is a narrow landmass that connects two large land masses. A narrow landmass that connects two large land masses. And what is the example, best example of isthmus? We find it here. Right. This is which continent? South America. And to the north, what do we have? North America. And here, what you can see? A narrow landmass. It is connecting South America with North America. So, what is the name of that place? It is the Panama. So, Panama is a country also. Is also an example of isthmus. Where you can write. Example is Panama. The Panama connects South America and North America. South America and North America. Yeah, Panama is also known for what other thing? Panama Canal. Okay, so we have dug a canal in east-west direction. What is this canal doing? It is connecting the Atlantic Ocean in the east again to what? Pacific Ocean in the west to some extent. So Panama is isthmus also, and then known for one of the grandest infrastructure projects in the entire world history. Two major projects we have that has reduced the traveling time and distance by thousands of kilometers. One is the Panama Canal, which is the other one? Suez Canal. Okay, both have reduced the time and the distance in the maritime navigation, shipping. Okay, imagine that if there is no canal and this side you have New York, right? This side you have San Francisco. So you have to come by ship from New York to San Francisco. What is the only way possible? You have to circumnavigate the entire South America. So imagine you go first south, again come north. Now by using Panama Canal, you can simply go from here to here. So this entire extra distance you are traveling has been significantly reduced. So very notable, very important infrastructure projects. So anyway, so that is the strait and isthmus. So these are something we had to discuss in the first chapter, that is basics of Earth. Okay, the motion of Earth, the division of Earth, strait, isthmus and all. Now the next topic or the second chapter we can write. Second chapter is internal structure of Earth. We have to start with the second chapter, that is internal structure of Earth. In the internal structure of Earth, the first attempt to classify was made by a geographer referred as Edward Suez. Edward Suez. Edward Suez. So Edward Suez says that Earth is made up of three main layers. He gave a very simplistic classification. We have three layers of the Earth. The uppermost layer he referred by what name? We call it as Sial. Uppermost layer. The uppermost layer of Earth he referred as Sial. And he says that the middle layer is Sima and the innermost layer is Nephi. So that is the simplest classification. Edward Suez classified Earth into three divisions: Sial, the uppermost part; Sima is the middle part; and Nephi is the central innermost part. Right? Why he is calling the uppermost layer as Sial? Because he says here you have a dominance of two elements. What are these elements? Silica and aluminium. So in the uppermost layer, he said uppermost layer, which is also the lighter layer. Lighter means low density. Uppermost layer is of low density. So this low density upper layer has a dominance of high percentage of silica and aluminium, and that's why he refers it as Sial layer. Then he goes further inward and says that the middle layer is made up of what? Silica is present here as well, but now aluminium is not dominant. Here we have dominant of which element? Magnesium. So that's why silica and Ma, magnesium, the Sima layer, silica and magnesium. And then he says that the innermost layer is the densest layer of the Earth. Densest layer. Densest means highest density. And why he is calling as Nephi layer? Because you have dominance of again two elements here, which are nickel and iron. Nickel plus iron. So Nephi layer. Right. So Sial, Sima and Nephi. Right, this is the simplistic model that Suez gave as far as the internal structure of Earth is concerned. Okay, but many times this later on, more detailed study, investigation was carried out, research was conducted, and then a more detailed picture about the Earth's structure was created or published. So that is what we have to focus upon. This is having nowadays historical importance largely. Okay, it is no longer used for explaining the Earth's structure and all that. So historically importance, because first model. Then we can write a statement we can add here that in the later years, based on direct and indirect evidences, in the later year based on direct and indirect evidences, a detailed picture of Earth's interior, was created. A detailed picture of Earth's interior was created and is referred as recent model of Earth, and is referred as the recent model of the Earth. recent model of the earth. Right. So, then we can write the next statement. The evidences collected were first, what is the first evidence? So first is lava sample. Okay, we know that on the earth we keep on experiencing volcanic eruption. So in the volcanic eruption, what comes out? The molten rocks which comes out. This is referred as what? Lava. So because lava is coming from inside of the earth, as it is coming from inside of the earth, that means it will bring all the information about the interior, what kind of materials, that means mineral you have, what kind of temperature, what kind of pressure and all that. This played a very vital role in understanding the structure of earth. So lava sample. Then next you can write. Next is direct drilling evidence or direct drilling based evidence. Direct drilling based evidence. Direct drilling based evidence means you are on the surface and you want to know what is inside the earth. So what you do? You start drilling a hole inside the earth. As you drill a hole, you know and become aware about all the places at a greater depth as such. So direct drilling based evidences. But what is the issue with this particular method? You can get very limited information. Why? Because you cannot drill till the center of the earth. Right? What is the distance between center and surface? That is the radius of the earth. Forgot, in physics you would have studied this. What is the radius of the earth? Roughly 6,400 kilometers. So imagine that this is the surface and the center is at the depth of 6,400 kilometers. And the deepest hole which we have drilled till date is only how many kilometers? 12 kilometers. Right. So imagine that the deepest hole we have drilled is only 12 kilometers and the center of earth is 6,400 kilometers. That means if you want to know the entire interior of earth, this is giving us just a minute or fraction of information. So that is the issue. So we can write this direct drilling. The maximum depth up to which we have drilled is just 12 kilometers. So very limited, very less information, limited or less information. Achha, where is this deepest hole? This also is an important fact to remember. So the deepest hole on the entire earth which humans have drilled is located in Kola Peninsula. Okay, it is near Arctic, and it was drilled when Soviet Union existed. Right, modern day Russia. So Kola Peninsula, Arctic, deepest hole which we have drilled till date. So that is the second. Third is we also studied the solar system and the meteorites. Solar system and sample of meteorite sample. That also give us a rough idea and some additional information about the Earth's interior. Solar system means the study of planets, asteroid and all that, because the entire solar system has a common origin. The entire solar system has evolved from the same place, originated from the same place. So based on that we can make some assumptions and some relations. Solar system. Achha, what is meteorite? Okay, you would have heard about this term. What is a meteorite? What happens in the outer space? You have a lot of rocks and metallic objects, rocky or metallic object we can say. Many times they get attracted or pulled by the gravity of the earth, because all of them are also continuously revolving around the sun. So many times when the earth is in its journey, meteorite is also in the same path. They get pulled by the earth's gravity. So as they began to be pulled by earth's gravity, most of them are destroyed. Why? Because they have to pass through the atmosphere where they are facing atmospheric friction and heat. So large part of them gets burned but still some part, if they are very large meteorites, some part of that cannot be fully burned, and then they fall on the surface of Earth. So that object that fell on the Earth's surface, what we are calling it as? That is meteorite. So it is a kind of the celestial body or a part of celestial body. So meteorite sample we have collected, and then we try to analyze that what kind of minerals more we have on the meteorite. So here example you can write is Hoba. It is the largest meteorite till date that we found on the Earth. Largest on Earth. There can be larger, but we have not found yet. But till date, the largest meteorite sample which we have found is referred as Hoba, and Hoba is in the Namibia is a country in Africa. So Hoba meteorite. It is in the Namibia region of Africa. So solar system meteoritic sample. Fourth is gravitational study. And the other way to understand the interior of Earth is by gravitational study. Right? Gravitational study means, like one example can be the measurement of value G. You would have used it in solving physics equations. Okay, what is the value of G that you consider? 9.8 okay, meter per second square. So the value of G generally we assume same everywhere on the Earth, but exactly it is not same. It varies from place to place. In polar areas, G will be different from the equatorial areas. Why? Because G depends on the amount of mass. The mass distribution is not same at the equator and the pole, because Earth is not perfectly spherical object. So if you measure the distance from center to pole and measure distance from center to equator, which is longer? Think about the Earth. Earth is kind of bulging at the equator. The distance from center to equator is longer, and at the pole it is kind of compressed. So that distance or radius is relatively small. So it is obvious that at polar areas gravitational force will be, or gravity value will be lesser. At equator what will have? At pole it will be stronger. At equator what will have? Right, because gravity we are assuming coming from center of gravity. As you move away from the center of gravity, G keeps on reducing. So equatorial region is far from center of gravity. The polar area is near the center of mass or center of gravity. So you do that, make that calculation, and based on that you understand how mass is distributed all around the Earth as such. Yeah, so gravitational study. So all of these were giving us very fractionated, fragmented of this information, but the major breakthrough was achieved when we began to analyze seismic wave to understand the Earth's structure. This is the most important one, which has given us all the modern this recent day data and information. Seismic wave analysis. Seismic wave are the waves that are generated when you have which kind of event? Earthquake event. Yeah, so during the earthquake, seismic waves are generated, and we then analyze these seismic waves. A detailed and accurate picture that we can write. It was after the study of seismic wave, we were finally able to get a detailed and accurate picture of Earth's interior. So we'll discuss that in earthquake chapter, the characteristics and the type of seismic wave and all. For now, here simply we can write the seismic wave analysis. Imagine that it is like X-ray. For example, if you have some accident, how would you know that everything is safe inside your body, your bone is not broken? You go and stand in the front of X-ray machine. X-rays pass through your body, and then what you can do? You basically get this information on the other side, and it gives you everything, all idea about the interior of your body as such. Similar way, when the earthquake event happens, it is not that seismic wave are moving only in the surface areas. They pass through the entire interior of Earth, right, from one part to the other part extreme. So what they are carrying? All the information about the Earth's interior. When you plot them, analyze them, you will be able to get a kind of internal picture itself. So we'll discuss that in earthquake how it is. So now simply we can keep in mind the seismic wave, it was a game changer. It is this analysis that provided us the most detailed, accurate picture of the Earth's interior, which is used to construction of the recent model, right? So lava sample, that is volcanic eruption, direct drilling, solar system, meteorite study, gravitational study, and seismic wave analysis. All of this has to some extent help in the recent model of Earth. Now we have to draw. How do we define the recent model of Earth? So we can write Earth's interior. This is the exact interior which we have to keep in mind. Earth's interior. So imagine this is the Earth. We are measuring everything from center. So this is surface. This is the center of Earth. And this is the uppermost surface of Earth. Now the name of layers we also have changed. So the uppermost layer, which this was referred as Sial, now we refer by what term? We refer it as crust. Okay, so the uppermost layer, based on the recent model, the uppermost layer of Earth is referred as crust, crust of the Earth. The middle layer is referred as mantle, and the innermost layer is referred as core. So crust, mantle, and core. These are the three layers of Earth. Three layers of the Earth. Then later on, scientists further divided these layers also into two parts. So today, the crust itself is classified into two types: the upper crust, and then we have the lower crust. Similarly, mantle is classified also into two types. The upper part is referred as upper mantle, and then we have the lower mantle, and the core is divided as outer core and the inner core. So total three major layers, within that 6 divisions. So upper crust, lower crust, upper mantle, lower mantle, outer core and inner core. If you look at the depth of each of the layer, so you start from the surface, that is 0 kilometer, you assume 0 kilometer. The upper crust extends roughly up to depth of how many kilometers? 30 kilometers. And the lower crust exists up to a depth of roughly 180 kilometers. So depth is very important. Question based on the entire depth and the arrangement on the basis of increasing decreasing order they have asked. So 0 to 30 kilometer is the upper crust, 30 to 180 kilometer is the lower crust. After that, which layer do you enter? Upper mantle. So upper mantle extends roughly up to a depth of 730 kilometers. 730. Up to 730 kilometers is the upper mantle. Then at a depth of 2900 kilometers is the lower mantle. 5150 kilometers is outer core, and 6370 kilometers is the center of Earth. Right. So these are the depth of the layers from surface to center. Understood? Right. Then we can write next one. What we see actually is that if you go from surface to center, two things are increasing. What is increasing? First of all, the temperature, and second is the density. So uppermost part is having lowest temperature, lowest density. The innermost part is having what? The highest temperature and highest density as such. So one statement you can write separately somewhere, that from surface to center, both temperature and density, from surface to center, both temperature and density continuously increases. Both temperature and density continuously increases. And how it increases? So we can show by plotting or writing the values. So for example, in the upper crust, density is roughly how much? 2.0. So all density will be measured in which unit? Gram per cubic centimeter. That is the unit of density which we are considering for this model. Gram per cubic centimeter. So in the upper crust density is around 2 gram per cubic centimeter. In lower crust, it becomes roughly 2.5. 2.5, some layer we have 2.8 also. So 2.5 average we can consider. In the upper mantle, density suddenly jumps and is found to be in the range of 4.6 to 5.2. Average density is in the range of 4.6 to 5.2 gram per cubic centimeter. In the lower mantle, it jumps again and becomes around 6.8. 6.8. In the outer core, it goes up to 10.0. In the inner core, it goes up to 13.0. And at the center, it is somewhere between 15 to 17. All are in the same gram per cubic centimeter. So that's how density varies from surface to center. The values in different layers are shown. Right. Achha, why density is increasing? Two reasons. One, nature of material changes. So you have more denser and denser material where as you go inside the earth. And second is, like if you talk about the upper mantle, it is carrying the weight of entire crust. Lower mantle is carrying the weight of entire crust plus upper mantle. Right. Outer core is carrying the weight of the entire upper layer. Inner core is carrying the weight of the entire, right. We have the upper layer. So what is going on? Pressure continuously increases. As pressure continuously increases, what happens? Density also increases. So that is the reason. Both because of the change in composition. Density changes because of change in composition and increase in pressure. Both of them can be considered a reason behind increasing density. The change in composition and increase in pressure. Done? Understood? So that is about the density changes. Then other, which is the most important point from exam perspective actually, which we have to study here, is that when you move from one layer to other layer, what scientists found when they analyze the seismic wave is that there is sudden discontinuity in their plotting. Okay, sudden discontinuity means, like for example, in upper crust, seismic wave is moving, its velocity is continuously increasing 1, 2, 3, 4, 5. Suddenly, when it enters the lower crust, what happens? There is a break. Density, the velocity suddenly increases from 4 to 6, for example. So there is no 5. Right. So what we can say, there is a kind of break or discontinuity. Again, it is moving for 5, 6, 7, 8. Again, when it enters from lower crust to upper mantle, what is going on? There is a sudden discontinuity jump. Velocity goes to 11 km per second, 12 km per second and all that. So they thought that there must be some sort of discontinuity existing between each of the layers of the earth. Why there is a discontinuity? Because again, the material changes, composition changes, phase changes. So we can write a term here and then I'll try to draw this. The term is discontinuity zones. Discontinuity zone. This is what we have to study inside. discontinuity zones. And we can explain them. What is the discontinuity zone? These are the zones. These are the zones located near. These are the zones located near
Sir, around 12:50, 55, I'll send the mentors. They'll be onboarding to them that mentorship portal. Okay. So you just inform the students also not to leave. They'll be assigning the mentors today.
Okay.
Okay. And also the online students, sir. You just inform them. Don't end the class. Okay.
12:50, no?
Yeah. 12:50. Okay.
Right. So we have what we're discussing about discontinuity zone. These are the zones found near the boundaries between the Earth's layer. Found between the Earth's layer. Found between the Earth's layer. Earth's layer, along which the velocity of seismic wave, along which the velocity of seismic wave suddenly changes, along which the velocity of seismic wave suddenly changes due to change in density of the layer. Change in the density of the layer. Right. So as you move from one layer to other layer, you find a discontinuity zone because there is a sudden jump in the velocity of seismic wave. Right. So that means we can say between each of the 6 layers that we have identified, what should exist? Some sort of discontinuity. So the first discontinuity zone you will find is between which layers? Upper crust and lower crust. Now what you have to remember from exam perspective is the name of discontinuity and which discontinuity zone is found between which of the layers of the earth. So upper crust and lower crust. This is the first discontinuity zone referred by what term? Conrad. Yes, we can write. You can show in the same diagram itself discontinuities. So first discontinuity is between upper and lower crust, and that is named as Conrad. Name is simply based on the scientist who identified it first. So Conrad discontinuity zone. Conrad discontinuity zone. Then second discontinuity you will find between which layer? So lower crust and upper mantle. This is the discontinuity referred as Moho discontinuity zone. Moho discontinuity zone. Moho discontinuity zone. Then further, next discontinuity you should expect between which layers? Upper mantle and lower mantle. So between upper mantle and lower mantle, the discontinuity zone is referred as Repeti discontinuity zone. REPETTI. Repeti discontinuity zone. Then the next is between lower mantle and outer core. Fourth discontinuity zone referred as Gutenberg discontinuity. Gutenberg discontinuity zone. And the last is between the outer core and inner core, fifth one. It is referred as Lehman discontinuity zone. So these are the 5 discontinuities between the six layers of the Earth: Conrad, Moho, Repetti, Gutenberg, and Lehman. Right. So what is happening along all these discontinuity zones? As you pass from one to other, you have sudden jump, sudden change in the velocity of seismic wave, because the composition, density, everything is changing here fast. So that is the name of five most important discontinuity zones as such. Now, other thing that increases is what? As you go inside the Earth, temperature. So temperature, by the time you reach the surface, like for example, when you reach here at junction, if you measure, temperature at this junction is in the range of 800 degree to 1200 degrees Celsius. That is at the crust mantle junction. At the mantle core junction, if you reach here, temperature further increases and goes in the range of 27 to 3000 degrees Celsius. Right, junction temperature can represent here. And by the time we reach the center of the Earth, the temperature increases and is anywhere between range of 4800 to 5200 degree Celsius. So these are the temperatures at important junctions inside the Earth. Total 3 junctions we can identify: T1, T2, T3. Crust mantle boundary, mantle core boundary, and finally at the Earth's center. Done? Clear? Right. So that is the overall discontinuity zones and temperature. Now see, two things we see. First of all, temperature is increasing. That means we know for sure that inside the Earth it is very hot. So if it is very hot, there must be some source of heating. So what is the source of heating? That we have to describe. We can write the sources of heat inside the Earth. Heading we can give is source of heat inside the Earth. So two major sources scientists believe is the reason behind such a high temperature. The major contributor, or the largest contributor of heat inside the Earth, is believed to be the radioactive decay of minerals. Inside Earth you have many radioactive minerals. They undergo natural decay. So radioactive decay of minerals releases humongous amount of energy. Example, which minerals are radioactive? So uranium, then what else? Plutonium. Then what else? You have potassium. Potassium also is radioactive. Potassium converts into argon. So uranium, plutonium, potassium, radium. Okay, so large amount of such minerals are found in the mantle region further down. So they undergo radioactive decay and heats the Earth's interior. Largest contributor of heat. Second is believed to be the primordial heat. The other source of heat is primordial heat. Primordial heat. Primordial heat refers to the heat that was contained or present inside Earth since its origin, because Earth originated from nebula. Nebula is something like stellar structure, star-like structure. So we know that stars are what? Very hot. So anything that comes out from a star, it still will have large amount of energy itself. So that is referred as what? primordial heat. So we can write in single line that it is the heat present in earth since its origin. It is the heat present in earth since its origin. So these are the two sources that heats up the entire interior of the earth, and that is the sources. And then we find one more contradiction here. Like we have two core, one is the outer core, other is the inner core, and we know that as you go inside, what is happening? Temperature increases. So we know for sure that between inner core and outer core, which will be at higher temperature? Inner core will be at higher temperature. Achha, composition wise both have same composition. Outer core also has largely which kind of elements? Iron, nickel. Here also what do we have? Dominance of iron and nickel as such. So what we expect, that inner core is at high temperature, that means here these metals and rocks would be in molten phase. Outer core may or may not be molten. But what we observe is the exact opposite. Outer core is found to be in which phase? Liquid phase. While inner core is found to be in which phase? Solid phase. So this is a statement we can write. The study of core show us that the inner core is in solid state. So as that inner core is in solid state even at higher temperature. Inner core is in solid state even at higher temperature, while outer core is in liquid state at lower temperature. Outer core is a liquid state at a lower temperature. Okay, naturally what we should experience? Reverse. Okay, where temperature is high, there probability or possibility of melting is more. So inner core is in solid despite temperature is high here. Outer core is liquid despite temperature is low here. Right. So what is the reason behind it? That we can write. So we can write the explanation. First of all, understand the contradiction. What is the contradiction? If you are heating something more, it should melt easily. Here you are heating it more, still it is not melting. Here is same material, you are heating less, but still it is melting as such. So the explanation behind this point we can write. It is due to extremely high pressure. It is due to extremely high pressure in the inner core. Extremely high pressure in the inner core. And what is the expected value of pressure that we can write in the bracket? What is the existing pressure? 1 to 3 million atmosphere in the inner core. Extremely high pressure, that is how much? 1 to 3 million atmosphere. To understand the pressure that we experience around us due to the atmosphere is how much? 1 atmosphere. Here how much is pressure? 1 to 3 million times higher than what we actually experience. Okay, so you can imagine. So 1 to 3 million atmosphere. The melting point, continue, the melting point of the material increases. Melting point of the material increases. Thus remains in solid phase. Understood? What is going on? Inner core has high temperature, no doubt about it. But also inner core has to bear the weight of the entire uppermost layer, right? Including core, mantle and crust. That's why pressure here also is very, very high. When pressure increases, generally what we see? Melting point of the materials also increases. So those